drawn from the right angle to its opposite side, the hypotenuse, it creates a new right triangle which are similar to each other and to the given right triangle. So for here, let's say for example, given triangle LOV, right angle O, an altitude drawn to the hypotenuse LV. So an altitude OE is drawn to the hypotenuse LV. So how can we solve the values of x, y, and z? So solve for x, y, and z. So how can we solve the values of the unknowns? First, we are going to break the original triangles into the three different triangles. So we have our smaller triangle. Let's say this is our smaller triangle, our bigger triangle, and our original triangle. So don't forget that it is right angle here. Right angle. So now, let us label first our original triangle. We have triangle LOV. So our LO is y. LV, we have 18 because 6 and 12 is equal to 18. And OV is Z. Next, our bigger triangle, this angle here corresponds to the angle in the original triangle. So therefore, this side here is V, this point. And our right angle, we are right angle at E. So this right angle here is E. And for our top side, we have here O. Now, here in our smaller triangle, it is also right angle at E, right? So our right angle here is E. And notice this angle here, this vertex corresponds to the original triangle L. So therefore, our top vertex here is L, and this corresponds to O. So we have now our three different triangles. So that's how you separate and break it into three different triangles. Now, what we'll do next is to find its proportionality statements. But first, let us define the similarity between these three different triangles. Now, we now have triangle. Let's start with the original triangle. Triangle LOV is similar to triangle or bigger triangle OEV. It is also similar to the smaller triangle LPO. Now, since we have our similarity notations, we can now compare the three similar triangles and get its proportionality statement. So let's try to compare smaller triangle and the bigger triangle and try to find if we can solve an unknown. So first, label it first. LE is 6. LO, we have Y. EO, we have X. EO again is X. OV, we have Z. And EV, we have 12. Now, getting its proportionality statement, we have LE over OE, or EO, is equal to the hypotenuse LO over OV. Again, it's also equal to the leg EO over EV. Now, plotting the values, we can create or we can solve the values of the unknown. So, plotting the value of LE, we have 6. So 6 or OE is X. LO is Y. And OV is Z. Equal to EO, we have X. And EV, we have 12. Now, as you can see, we have three different variables here, so don't worry. Notice that the first proportion and the third, we can solve for the value of x. So we can pair it up And using proportion, we can solve for the value of x. So we now have 6 over x equals to x over 12. Now, cross multiply, we can have x squared equals 6 times 12, we have 72. Getting the square root of both sides, we have x is equal to positive, negative, square root of, what is square root of 72? It is just 36 times 2. Times 2, we have x equals positive, negative, 6 square root of 2. Since this is a measurement, we are going to accept the positive number. So we have x equals 6 square root of 2. So that is the value for our x. Now, even if you substitute the value of x in our proportionality statement, we can find the value of y or z here because these are two unknowns or two variables. Now let us try to compare or find the proportionality statement of the bigger, say the bigger, and the original triangle. So let's try it here. We have OE over LO equal to the hypotenuse OV over hypotenuse LV of the original triangle. Also equal to the leg EV over OV. Now by plotting the values, we can have OE as x, or simply OE is simply 6 square root of 2. Instead of x, you can write 6 square root of 2. 6 square root of 2. Our LO, we have y equal to OV. Our OV here is z. And our LV is 18 equal to EV, we have 12, and OV equals z. Now, notice, you can also use this pair of proportion and find the value of z. Now, z times z is just z squared, and 12 times 18 is equal to 216. So, getting the root of both sides, we have z equals positive, negative square root of 216. 216 is just z equals positive, negative square root of 36 times 6. So, we now have the value z equals positive, negative 6 square root of 6. 6. Now, we are just going to accept the positive value. We have z equals 6 square root of 6. This is the value for our z. Now, in order to solve for y, we can just substitute already the value of z because our z here is just equal to 6 square root of 6. Plus 6 square root of 6. Now we can substitute the value of z here in order to find the value of y. So we have 6 square root of 2 over y, plus instead of z, let us substitute or plot the value of z equals 6 square root of 6 over 18. Now cross multiply, we have 6 square root of 6 of y is equal to 18 times 6 square root of 2. 6 square root of 2, we have 6 square root of 6 of y is equal to 18 times 6 square root of 2 equals 108 square root of 2. Divide both sides by 6 square root of 6 to get the value of y. Cancel. We now have y is equal to 108 over square root of 2. 108 square root of 2 divided by 6 square root of 6 is equals to, you may use your scientific calculator. The correct answer here is 6 square root of 3. Now, we have the value of y. Now, if you are not sure if what you get to the value of y is correct, you can simply use Pythagorean theorem to check using this original triangle, since we now have the length of the hypotenuse and the length of the leg. So you can use the Pythagorean theorem. The Pythagorean theorem says the square of the hypotenuse is equal to the sum of the square of its legs. So c squared equals a squared plus b squared. So our hypotenuse here is 18, so we have 18 squared equals a squared. Let's say our a here is y, so we have y squared plus b squared, let's say z, so 6 square root of 6 squared. Now, we have 18 squared is equal to 324 equal to y squared plus 6 square root of 6 squared is equal to 216. So, we can now subtract both sides by 216. We have y squared is equal to 108. Get the root of both sides. We have y equals positive negative square root of 108. So, square root of 108 is just equal to square root of 36 times 3. Now we have y equals positive negative 6 square root of 3. Getting only the positive value, we have y equals 6 square root of 3, which is equal to what we have solved earlier. So, what I did is just simply checking if our answer using the proportionality statement is correct. However, you can use Pythagorean theorem to solve the missing sides of a right triangle, because as what you can see here, there are given lengths which satisfies the Pythagorean theorem, because this is a right triangle. So for here, the smaller triangle, the leg 1, 6, and x equals square root of 2 is already given, so you can just find the value of y, the hypotenuse, using Pythagorean theorem. Also, for the bigger triangle, the leg is already given and the hypotenuse is given, so you can simply use Pythagorean theorem to solve for the value of x. So, you can simply use this formula in order to solve the missing values of a right triangle. So, this is how we solve for the unknowns using the right triangle similarity. So, we now satisfy here the values of x, y, and z. We have x equals 6 square root of 2, y equals 6 square root of 3, and z equals 6 square root of 6. So, this is the answer for this given problem. That's all. Thank you.